In this demonstration, I'll show you how to convert or transform a polar coordinate equation into rectangular coordinate equations, aka Cartesian equation. The question reads, transform the polar equation r is equal to cosine theta to rectangular coordinates. So what that means is that this equation currently is in r and theta, and they want us to convert it in terms of x and y. To do that, you need to look at all four of these formulas and replace all instances of r with x and y and all instances of theta with x and y, and then subsequently solve for y. So make it y is equal to. I can first replace this r with the following. And if I do that, this is what happens. Instead of writing r, I write down x squared plus y squared. And next, what I need to do is replace this cosine theta with an x and y. But there are no equations that will do that directly. So what we will need to do is focus on this first equation. And what I'll do, and I'll just erase this for clarity's sake, I'll write that equation down and I will solve for cos theta. Let's do that. If I solve for cos theta, I have to divide both sides by r, and I end up with x over r is equal to cos theta. And I'm going to replace cosine theta with x over r. Now, that doesn't help us very much because still this equation is not in terms of strictly x and y. It has an r. So what we have to do next is replace this r with something that represents x and y, and this looks like the equation to do that. So let's move forward. X squared plus y squared, I'm just rewriting the part that hasn't changed, x over x squared plus y squared, and there you have it. So technically you can argue that you've successfully converted this polar equation into rectangular coordinates, but it still has to be in terms of y is equal to. So how do we make this in terms of y is equal to? Well, first I'm going to move this down here so we have more space. And what we will do is to solve for y, I'm going to get rid of this part right here. And I can do that by multiplying both sides by x squared, y squared. And similarly, if I do that to the right side, I also have to be generous and do it to the other side. If I multiply this side by this expression, this part cancels out, and I end up with x is equal to this multiplied to this. Now, if you multiply two square roots, let me give you a sample. This gets rid of these square roots, so you end up with just a. And in another video, I'll show you why that is. But let's concentrate on this. So we end up with x squared plus y squared is equal to x. We'll next move this over to the other side where we get x minus x squared, y squared, and our y value, we isolate it by square rooting both sides to get the square root of x minus x squared. That is question 1 of 2. I'm going to show you the next question below. So in this case, they want us to convert r is equal to 3 tan theta to rectangular coordinates. Now, I'm going to use the same technique as before, where I will replace this r with the following. X squared plus y squared is equal to 3 tangent theta. This part right here is problematic because it's in terms of theta and it needs to be in terms of x and y. So what we can do is we can use the following formula and rearrange it for tangent theta. Let me show you what I mean. That formula currently does the following, or looks like the following. Arc tan y over x is equal to theta. Now we have a tangent here, not arctan. Arctan represents the inverse of tangent. So let's write this down in a way that we understand it better. There you go. And what I'll do is bring it back to its original form. Tangent theta is equal to y over x. So what we can do is replace tangent theta with y over x. Let's do that. I'm going to rewrite the part that I haven't changed. I'm going to leave this 3 there and replace this tan theta with y over x. Perfect. Now we have to solve in terms of y. And the way we do that is, well, there's several ways you can do this, but the most efficient way would be to square both sides right from the get-go. Because what that does, when you square both sides, squaring a square root will eliminate the square root, leaving with just the content inside. So on the left side we end up with this, and on the right side we end up with 3 to the power of 2, which is 9, and this part to the power of 2, which is equal to y squared and x squared. We're almost there. Next, what we will do is multiply the right side out. We end up with 9y squared x squared. And on the left side, we have the following. Next, what we will do is multiply both sides by x squared. Because by doing that, the x squareds here cancel out. We end up with 9y squared. And on the left side, we have x to the power of 4 plus y to the power of 2, x to the power of 2. Furthermore, we will take this term over, and I'm just going to continue my work up here. And we end up with x to the power of 4 is equal to 9y squared minus y squared x squared. And we will pull out this y squared from both of these terms to get 9 minus x squared, x to the power of 4 on the left side. And we still want to isolate for this y, so what we'll do next is divide both sides by 9 minus x squared. This cancels out with this, and on the left side we end up with 9 minus x squared. And we end up with y squared is equal to x to the power of 4, 9 minus x squared at the bottom. We still haven't officially isolated for y because there's a squared there. So what we will do is we'll square root both sides, where we end up with y is equal to x squared, and at the bottom we end up with the square root of 9 minus x squared. There you have it, folks. That is how to solve or how to convert a equation that is in polar form to one that is in rectangular coordinates. Now, if you're looking at this, you might say, well, this is a difference of squares and therefore you can factor this out. Yes, that is true. If you have any other questions related to this, these 2 questions that we did, use our website at biology-forums.com or comment below. And if it was helpful to you, please like this video. See you soon.